Good day, sir. Good day, everyone. My name is Cadet Michael Iragasi, and I am here with my fellow cadets, Cadet Liston, Cadet Limbaga, Cadet Pardillo, Cadet Kimbo, Cadet Royeras, Cadet Reyes, and Cadet Sabalia, and we are group number 3. We will describe the importance of ship's turning circle in ship handling and compare the turning circle in ballasted condition to the turning circle in loaded condition. So without any further ado, let's start. Turning circle. Turning circles and stopping distances is the advance of a ship for a given alteration. Of course, is the distance that her compass platform moves in the direction of her original line of advance, measured from the point where the rudder is put over. The transfer of a ship for a given alteration, of course, is the distance that her compass platform moves at right angles to her original line of advance, measured from the point where the rudder is put over.
Good day everyone, I am Cadet Reyes and the following factors determine the acceleration power of the ship. First is the momentum of the ship depends upon the mass of the ship and the speed of the ship. Thus a lighter ship will gain or lose speed faster than a deeply loaded ship. Next one, if a large tanker is taken an example, then at the same speed it will travel long after the engine is stopped. When the tanker is in full load condition, the reverse will happen when the tanker is on ballast. That is it will travel as lesser distance. For starting up also, after the first movement is given or loaded tanker will come to the designated speed slower than the same tanker when it ballast.
So, good day, sir. This is Cadet Magilimutan. And also, one of the factors determining the acceleration powers of a ship is the shape of underwater part of the hull also plays an important part. Two tankers of the same displacement would have entirely different accelerating and decelerating speeds. The tanker which has finer lines than the other would be able to travel farther after the engines are stopped, as well as start in each the design speed faster. Another factor is the condition of the ship's bottom and underwater part of the hull. If the other sides are fouled with marine growth, then there will be a drag and the effect on the startup would not be affected, but the travel distance after the engines are stopped would be shorter. And also, if the underkeel clearance is low, then the effect is both ways that our ship will take longer to reach her design speed from stop, as well as she travels longer when the engines are stopped.
Good day everyone, I am Cadet Liston and I'll be the one who will report this slide. Factors affecting speed. Fall bottom. If a ship lies for long in harbor, particularly in a tropical harbor, her bottom becomes fouled by winds, weeds, barnacles, and other marine parasites or growths, and the speed attainable with a given number of revolutions is reduced. Shallow water. When a ship is moving in a shallow water, the gap between the ship hull and the bottom is restricted. The streamlined flow of water past a hull is altered, and the result is seen as a greatly increased transverse wave formation at the bows and gain at the stern. In fact, the increased size of the stern wave is sure indication of the presence of shallow water. The energy expended in the waves formed by the ship is a loss from the water available to drive her, and therefore in shallow water her speed is reduced.
Good day everyone. Good day sir. I'm the Cadet Pardillo Manuel Jr. So, factors affecting a ship's handling qualities. Draught, trim, and loading. On a general cargo ship or tanker, the difference between the turning qualities when lightly laden and when fully laden is very marked. When deeply laden, a cargo ship has a much longer turning circle than when lightly laden, and she is more sluggish in answering her rudder. Less. The effect of a less is to hinder you a turn in the direction of the least and assist a turn away from it. A least to port decreases the tactical diameter of a ship turning to starboard and vice versa. Speed. The effect of speed on tactical diameter will vary from one type of a ship to another. Often, higher speed may lead to a greater tactical diameter because the rudder may stall. Modern rudders on a smaller ships, however, are able to operate satisfactorily at higher water speeds and greater angles, and hence the tactical diameter may not vary much with speed. Shallow water. These effects may become excessive if the depth of the water is less than 1.5 times to drought, particularly if the ship enters such water at high speed. She may become directionally unstable and fail to answer her rudder at all, and the draft up may increase so greatly as to cause the propellers to touch the bottom.
Good day, I am Cadet Kimbo Eljanjoy and I'm gonna report about effect of hull from on turning circle. A ship of the fine underwater form or container ship will turn in a larger circle than a ship of similar length and draught, but of the fuller form, the tanker, modern container ship are generally of great length in proportion to beam and thus tend to have large turning circles. The ship of the underwater part of the hull aft, particularly the cut-up area, as shown in figure, has a most important effect on the size of the turning circles. Effect of cut-up area on turning qualities. The ship with a larger cut-up area, ABC, will have a smaller turning circle than the one with a smaller cut-up area, ADC. Effect of single crew on turning circle. In a ship fitted with a single right-handed fixed pitch screw, or most of the ship, the sideways force exerted by the propeller creates a tendency for the ship to turn to port when going ahead. With a left-handed controllable pitch propeller, the effect is reversed, the ship turning more easily to starboard. Hence, the turning circle with this type of propeller is usually of smaller diameter when turning to starboard than when turning to port.
Limbaga. Slide 8. Turning. Effect of a turning of a speed. The effect of drag, the rudder, and the sideways drift of a ship will result to progressive loss of speed while turning, even though the engine resolution are maintained at the constant figure. For alternation of course of up to 20 degrees, the reduction of speed may not be very great, but for those between 20 degrees and 90 degrees, the speed usually falls rapidly. For alternation exceeding 90 degrees, the speed may continue to fall slightly, but it usually remains more or less steady. The rate of acceleration depends upon the initial speed of the ship and the angle of the rudder applied, and it varies greatly between different types of ship.
Good day, sir. I'm Cadet Ivan Sabalya. I'm here to discuss the hail wind turning. So, the initial hail when the wheel is put over is inwards because the rudder force is acting at a point below the center of the gravity of the ship. As the ship begins to turn, the centripetal force on the hull, which is greater than the rudder force, acting through water pressure at a point below the center of gravity, overcomes the tendency to hail inwards and causes her to hail outwards. This outwards hail is very noticeable when turning at a good speed. If the wheel is eased quickly, the angle of the outward hail will increase. because the counteractive rudder force is removed, while the centripetal force remains until the rate of turning decreases. Next, compare the turning circle in ballasted condition to the turning circle in loaded condition. So, turning circle as the turning ability in fully loaded condition is much larger than that in ballast condition in some cases, or the turning circle in trim by stern condition as larger in even keel condition. Furthermore, the sea trial test for new ship is mostly executed in ballast condition.
Cadet Rueras Ranger F. Slide 6. Compare the turning circle in ballast condition to the turning circle in loaded condition. Turning circle as the turning ability in fully loaded condition is much larger than that in ballast condition. In some cases, or the turning circle in trim by stern condition has larger in even keel condition. Furthermore, the sea trial test of new ship is mostly executed in ballast condition. Thank you.